Pre-Algebra, Mr. Lawrence here with your flipped lesson. This is the review for the test. Hopefully you check this out more than once. We are going to start our test probability. Remember we began with the fundamental counting principle. All right. And that said, if one thing happened 4 ways and another thing happened 5 ways, together they happen the product other ways. 4 times 5 is 20. Okay, the official definition is something like if one event happens m ways, another one happens n ways, and together they happen mn ways, meaning you multiply the two together. So if I have 3 shirts, 4 hats, 5 pairs of pants, and 2 pairs of shoes, how many different outfits can I make? And remember, we're assuming that each outfit consists of 1 shirt, 1 hat, 1 pair of pants, and 1 set of shoes, 1 pair of shoes. Well, I can take 3 times 4 times 5 times 2. And I know that this is 20. And I know 3 times 20 is 60. And times the 2 that I didn't use, that is 120 different outfits. And notice that, excuse me, notice that I labeled my answer. I didn't just write 120. I don't want to be lazy about this. All right, now the fundamental counting principle we use throughout this unit, and we also did it for things like tests. Now, some of you get lazy on this, and this is why you're going to get it wrong. You don't want to get lazy. Let's say there are, oops, I lost my connection. I don't see my thing. Oop, there we go. Something strange just happened, but that's okay. Let's say you're going to take a 15 question test in social studies, and it's all multiple choice. All right, multiple choice, and we're going to go A through, say, C. All right, well, I want to know how many different ways there are to answer this. A lot of you are going to go 15 times 3, 45, and you're going to be dead wrong. It's not even close. It's not even close. I've shown you what to do, but some of you won't do that. First thing I want you to do is I want you to number the paper. Okay. Now, if you don't want to number all the way to 15, that's okay. You can use a smaller set, but I'm going to show you how to do it with 15. And usually on tests, you have plenty of time to do what you need to do. And the OAA is coming up next week, believe it or not. And if you show this kind of work on this kind of question, you are going to get full credit. All right, now ask yourself, how many choices do I have for the first question? Well, I have 3, A, B, or C. How many choices for the second question? 3 more, 3 more, 3 more, etc. There's 3 for all of these. Whoa, sorry about that. All right, so there's 3 for all of these. Okay, so let's see if I can do, there we go. There you go. Okay, so there's 3 choices for all. What am I going to do with all those 3s? Well, I'm going to multiply them together. But that's not 3 times 15. That's 15 3's being multiplied. Or you could say it's 3 to the 15th power. This is going to be one monstrously large number. Let me pull out a calculator here. This is going to be, oh, you know what? Instead of using a calculator, let me do this. Let me go to Google. I'm not sure if I've shown you this. If I haven't, check it out. Uh-oh, having a technical snafu. There's my search. Okay, now check this out. I'm going to type in 3. I'm going to put this little chevron kind of guy, this hat guy, to the 15th power. All right, and I'm going to hit enter. And Google is going to bring me the answer because it's like a calculator. 143 489 07. 143 489 07. 143 489 07. So my answer is 143 48907. I only did that to remember the order. Of course, I know how to read it. The answer is 14,348,907 different ways to answer this test. So those of you thinking you don't have to study, or if you figure, I won't study, and then you get crappy results, that's why. Only one of them gets you all of them correct. A few of them get you, missing one or missing two. But there are 14 million, over 14 million different ways to do this test. All right, so those are the main types of fundamental counting principle problems we did. And then we got into theoretical probability. And we said something like, remember the probability, we gave the definition, and the probability was the success over the total outcomes. All right. And, that says prop. It should say prob, right? So the probability. So when we need to know the probability of, say, flipping a coin and getting a heads, well, getting a heads would be the success. And there are two total outcomes. And so the probability would be 1 out of 2. The probability of rolling, say, a number less than 5 on a 20-sided die. Well, there are 4 numbers less than 5 on a 20-sided die, and there's 20 total numbers, and that would simplify into 1 over 5. Okay, along with probability, we can talk about odds. And odds, the odds of something happening is defined as success over failures. Very similar, but not the same thing. So if I want to know the odds of getting a heads on a coin, well, that would be 1 over 1. 1 success, 1 failure. The odds would be fair, even. Okay, the odds of getting a number less than 5, less than 5 on a 20-sided die, I have two choices. I could use this number and simplify, or I could use this fraction and simplify. This one is already simplified, so it would be easier. That's the one I want to use, but I'll do it both ways just to show you, just in case on the test you don't realize you could use this one. All right, well, there are 4 numbers less than 5 on a 20-sided die, and there are 16 numbers that are not less than 5. So simplifying that, I get 1/4, or 1 over 4. All right, if I take this one, there's 1 success. There's 5 total outcomes, but if I take away the 1 success, there are 4 failures. And there we go. This answer and this answer, they match. So it doesn't matter. Some of you would rather use this one because it kind of makes more sense, but you can use the simplified form and save yourself a little bit of trouble. All right, so some of our probabilities, we had to identify independent. Oops, I switched colors there accidentally. And now I'm pendant and dependent. And remember, independent were where the outcomes did not have anything to do with each other. For example, for the independent, what would be the probability of rolling a 1 on a 6-sided die and flipping a heads on a coin? Well, the probability of getting a 1 on a 6-sided die is 1 out of 6. The probability of getting a heads is 1 out of 2. Okay, the fundamental counting principle tells me to multiply these, and I get 1/12. 1 out of 12. Okay, every 12 times I do it, I would expect to win 1 time. All right, for dependent events, might be a situation like I have a deck of cards. And remember, there's 52 cards in a deck. There's 4 suits, right? The suits are hearts, diamonds, clubs, and then spades. Okay, and remember these two here are black, the clubs and the spades, and the hearts and diamonds are red. Okay, and each suit has a 2, 3, 4, 5, 6, 7, 8, 9, 10, a jack, queen, king, and an ace. And these three cards here are called face cards because they have faces on them. A picture of a jack, a queen, and a king. All right, so now that we've got the background there, what would the probability be of getting a king on your first draw and then getting, say, a queen on the second draw, and this is without replacement? Very important. You need to know if the first card is put back. If the first card is put back, these are independent events. But if the second card is not put back, like this says here, without replacement, excuse me, the first card is not put back, then they are dependent events because the first one happening affects the second one. So let's see, what's the probability of getting king? Well, there are 4 kings in the deck, and there are 52 total cards. Okay, now that fraction will simplify to 1 out of 13. What's the probability of getting a queen? Well, there are 4 queens in the deck, but there are only 51 cards left. Why? Because we drew 1 king out. All right. Now, I don't believe 451st simplifies, so I'm going to come over here to 451st, and I need to multiply 113 times 451st. I'm going to look this way. Nothing will simplify. Nothing simplifies here. Nothing that way. Nothing that way. So I can just multiply. My numerator will be 4. My denominator, I'll get 3. I got 15 and 1 is 16. Carry the 1. 5 and 1 is 6. 63. So it is not very likely that you will draw a king out and then draw a queen out. In fact, every 663 times you do it, you would expect to have it happen only 4 times. Okay, so that is independent and dependent probability. And then we talked about mutually exclusive and mutually inexclusive events. Mutually exclusive and mutually inexclusive, right? And the exclusive events are ones that cannot happen at the same time. They exclude each other. Okay, and inexclusive can happen at the same time, and so we have to account for it. So the mutually exclusive, we do pretty much like everything else. But the mutually inexclusive, let's say that you wanted to know the probability of reaching into a deck of cards, getting out a king, or getting out a heart. Okay. Now, there's only one draw, so you don't have to worry about a card being put back. You win if you get a king, or you win if you get a heart. Now, there's one problem here. I know the probability to get king is 4 out of 52, or better yet, 1 out of 13, simplified. The probability of getting a heart is going to be 13 out of 52. And then that does simplify to 1/4. The only problem is here, the king of hearts has been counted twice. He's been counted here, or I should say here, the unsimplified form, and he's been counted here. I don't want to count him twice. If I count him twice, my information is going to be incorrect. So what I do is I have to subtract off the possibility of getting the king of hearts, okay, 1 time. So what's the probability of getting king of hearts? 1 out of 52. All right, and hold on 1 second. Okay, sorry about this. I have one mistake here. I need to change something here. My probabilities are right, but I don't want to multiply them because it's only a one draw situation. So I've got the 4/52, which simplifies to 1/13, and I've got the 13/52. And I'm going to add these together, okay? And I could do this and do the 1/4 if I want, okay? Now I do have to subtract off, but what I'm going to subtract off is I'm going to subtract off the 4/52 times the 13/52. That's where the king of hearts happens twice. That's what I need to do. So I could do the 1/13 times the 1/4. Now I can work with this top fraction if I want, or the top problem right here, or I can work with this one. This one might be a little bit easier to work with. First of all, this will end up being 1/52. Here I need my common denominator, 4/4, and then over here I need to do 13/13. And so I'm actually unsimplifying these fractions. Okay. And so what I'm going to end up with is I'm going to end up with 17/52 minus 1/52, which is 16/52. And that will simplify. I think 4 will go into both of those. So it'll be 4/13. And so the probability of getting a king or a heart is 4/13. All right, what would the odds be? Well, the odds of that happening would be 4 to 9. All right, pretty simple stuff. All right, one more thing to talk about here, and that is permutations and combinations. All right, perms and combos. Remember, on the perm, the order matters. And on the combo, the order doesn't matter. Okay, so let's say we have a situation like, let's use racers both times. Let's say there's 20 racers. Okay, and in this case, first place is going to get a gold medal. Second place is going to get a silver medal. All right, I missed an L there. All right, and that is a perm because if John is in first and Sally is in second, that is not the same as Sally getting the gold and John getting the silver, right? That's not the same thing. So the order matters. So this is a perm. Now I'm worrying about two places. 1, 2. Okay. How many people have a chance to finish in first? 20. When somebody's in first, there are 19 left that could finish in second. And I'm out of spaces, so I just multiply 2 times 19 is 38. And then there's a 0. 380 different ways. All right. Okay. So let's look at a very similar situation. Let's say we have 20 racers. Okay. And the top 2 advance to the next round. All right. The top 2 advance to the next round. Well, let's see here. Let's say John finishes in first and Sally finishes in second. Is that the same as Sally in first and John in second? And it is the same because both of them, in the first case here, first scenario, who gets to go to the next race? John and Sally. In the second scenario, who gets to go to the next race, next round? Sally and John. It's the same thing. So this is a combo. So I care about two outcomes or 2 racers. I draw my fraction bar, and if I put 2 spaces upstairs, I put 2 downstairs, right? How many racers have a chance to finish in first? At the start, 20 and 19. Notice the combo looks just like the perm. Down here, this is the hard part. I put a 1 and I put a 2. All right, 2 goes into 20 10 times. All right, 10 times 19, 190 different ways that the 20 runners that could finish in the top 2 places. All right, so that's it. You can go back and watch some of the previous videos if you need to. You know, if you're weak on perms and combos, go back and watch the perm and combo video again. Check out some of your homeworks you did. I know you guys can do this. All right, and then next week we'll start getting ready for the OAs. All right, good luck on your test. Mr. Lawrence signing out.